Hello students, welcome to Alchemist Academy. So today our session will be on mole concept. It is from the 11th standard and the chapter is some basic concepts in chemistry. Okay, let's start the session. So regarding the mole concept, this particular concept is used when we are actually doing a chemical reactions in a laboratories. Now let's see, if you go in a market and if you wanted to purchase apples or oranges, how you are actually asking these oranges or apples in the market. So usually you are using a word dozens or kilos. These are the entities you are using, right? So here in chemistry, actually to measure the compound, to do a chemical reaction, we cannot use this kilos or dozens because this is a big entities. In chemistry, we are usually using a small entities. So the perfect entity to measure this compound is the mole. Okay, so today we are going to see how this mole concept is working. So let's see with some of the things here. To go with the mole concept, you need to know these four entities. Okay, so which are the four entities? Mass, mole, volume, particle, atoms and molecules. This I am placing in a one things. Okay, particles, atoms or molecules. Whereas this is mole, this is volume and this is the mass. Now when I am saying a mass, it is either atomic mass you consider or you can consider it is a molecular mass, depending upon which compound or which substance they have given us. If they have given us a particular atom, then it will be an atomic mass. If they have given us a molecule, then it will be a molecular mass. Okay, so let's see how this is working. Now before going to the problems and all, first I'll just teach you some basic concepts here. So what is the concept? A standard. So everyone should know how to write the standard. Now what is the standard? Standard for mole is always a 1. Remember that. 1 mole is always a standard. Whereas when I'm talking about a mass, this mass is nothing but an atomic mass or a molecular mass of that particular substance. That is the standard for a mass. When I am talking about a volume, then volume will be 22.4 liters. So volume standard is always a 22.4 liters, whether it is for the atoms or whether it is for the molecules. And mole is always a 1 mole. Whereas when I am saying either a particle, an atom or a molecule, here the standard will be 6.022 into 10 raised to 23. Okay, this particular number is also called as Avogadro's number and it is depicted by the symbol Na. So we will see some of the basic compounds and we will write the standard for these compounds. Okay, so if suppose I am saying oxygen atom, so how to write a standard for these oxygen atoms? So for this oxygen atom, the standard is, what is the oxygen? Oxygen is an atom, so that means you write the atomic mass of this. So atomic mass of oxygen is 16 grams, right? Mole is always, I have said, 1. Volume always it is 22.4 liters and particles is always 6.022 into 10 raised to 23. Now here it is the atoms. We cannot call it as a molecule because this is, I am talking about an oxygen atom. Okay, let me take some other entity here. So other entity I will take nitrogen, I will take molecule, I will take, now this is the atom, this is the molecule I will take. Now here to write the standard for this, write the mass for this. Now what is the mass you are going to write? This is a molecule, that means it is a molecular mass. So 1 nitrogen, you know that it is a 14. Yes or no? The atomic mass of 1 nitrogen is 14. Now here it is N2 is there. That means it's 2 times. So here you are going to take 28 grams. Correct? Here mole is always 1. Volume is 22.4 liters. And particles or molecules here I will say, not the atom, 23 molecules. This is the same. So like this, you can write the standard for n number of atoms or n number of molecules. Once you know the standard, how to write here, then it is very easy for you to go with the calculations. Okay. So now as you understood this, I'll just brush up the normal things regarding this. Now, if you see, we will try to go with the standard things. Carbon, when I'm saying a mass, it will be a 12 grams. Mole, I'll say 1 mole. Volume, 22.4 liters. And particles, molecule, it will be, I'll consider it as a N, right? This is how we are writing the standard for a carbon. What is the standard for nitrogen N2? We have already seen here, it is 28 grams. 1, this is 22.4 liters. This is N. Okay, next is NaCl. Now NaCl, what is the mass? NaCl is a compound, so it will be a molecular mass. Na is 23 and Cl is 35.5. So it comes to Na is 23. So 23 and 35.5. This is how we are writing the or finding out the molecular masses. So if you see here, this will be 5, this will be 8 and 0.5. Correct? So this I'll get 58.5 grams. Understood? So here 1 mole again, this is 22.4 liters and again this will be the N. Similarly, for this molecule, that is a sucrose, here the molecular mass for sucrose, if you calculate, then you will get a 342 grams. Here the mole will be 1 mole, volume again it will be 22.4 liters and Avogadro's number, that is particle, atoms or molecule, will be N. Again CH4 methane will be carbon is 12, hydrogens are 4. Total comes to 16 grams. This is mole is 1 mole, volume is 22.4 liters and this atoms or particle comes to again Na. So Na means it is 6.022 into 10 raised to 23. That is the Avogadro's number it is called. So once you know how to write a standard for each atom or a molecule, your 50% work is done. So any type of the problems you can try if you know this standard how to write the things. Okay. So next we will see the general idea regarding the mole concept. When I am saying the theoretical point of view that this many atoms, this many mass, then you will actually think about the how much atoms, how many atoms or how much mass is consist of. Don't go with the actual meaning of this. Okay, don't go. You just have to go with the basic things what is taught here. So don't go with how many atoms and how many molecules. Just go with the basics. Now what it is? Now when I am saying these carbon atoms are there here and copper atoms are there here. You see here when I am saying a carbon atom is a 1 mole. Here whatever atoms of carbons are there, it is a 1 mole. Then 1 mole of atom is how much amount it is? It is a 12 grams, which is nothing but an atomic mass of that. So 1 mole is nothing but 12 grams of that. Similarly, copper, when I am saying these many atoms of copper, that means this is called 1 mole. When it will be a 1 mole? When I am saying the mass of those many atoms will consist of 63.5 grams, which is the atomic mass of a copper. Now both the things, if you see here the molecules are smaller, here it is bigger. Don't go with the actual things here. That's what I have said. You see here this particular 1 mole or this particular 1 mole, both will be having same number of atoms. So the atoms in both the cases will be the same. That's what at the starting I have told you. Don't go with the actual meaning. It is smaller, then you will say that here more number of atoms are there, here less number of atoms are. Nothing like that. It will be like whenever I am saying a 1 mole of any element or any compound, it means that both the cases the number of atoms are same. That is 6.022 into 10 raised to 23. Okay. So next we will see with the problems. Okay. So we will see some problems now. Now here calculate the mass of 6.022 into 10 raised to 23 molecules of calcium carbonate. Now when they are saying this to find out this particular mass of these many number of molecules, now what you have to do is you have to just relate the two things. What we have seen in the mole concept, we have seen 4 things: mass, mole, volume and the particles, right? Now among these you have to relate any two relations. If you get, then it will be very easy. So your main job is to identify which are the two relations here. Now if you see here, calculate the mass. You got the word mass. Calculate the mass of 6.022 into 10 raised to 23 molecules. You got your 2 words. These are the relations. So here the relation between what? Mass and the molecule, right? Now you have to find out who is the molecule or who is that atom they are talking about. If you see here, they are talking about calcium carbonate. So I will write it at the corner. Once you get this, the things will be very easy. Now what you do, write the standard with respect to that particular molecule. When I am writing the standard of that, the mass depicts the molecular mass. Am I right? So what is the molecular mass of calcium carbonate? You can find out this. 40 plus 12 plus 3 into 16. It comes to 40 plus 12 plus 48. Correct? So if you see here, this comes to 52 plus 48, which is nothing but 100. So this is how we will find out the molar mass. So molar mass is a standard here. So standard is how much? 100 grams. Whereas molecule standard is how much? Avogadro's number, right? So it is 6.022 into 10 raised to 20. Okay. Now this is your standard. Now we will write as per this problem. So problem says what? Calculate the mass of. What they are telling you to find out? Calculate the mass. So this side I will put a x. And what they have said, these many molecules. So what is given? Molecules are given. So that molecules I will write this side. Okay. So once you are writing this, then it will be a simple cross multiplications. There are other methods with the formulas and all, but I am just telling you the methods which you don't require to by heart or anything. Once you understand the concept, directly you can go for it. Okay. So when I am writing this x into this, it will be 6.022 into 10 raised to 20 is equal to, this will be written as 6.022 into 10 raised to 23 multiply by 100. So this can be written as x is equal to 6.022 into 10 raised to 23 multiply by 100 divided by, this will come to the base of this, 6.022 into 10 raised to 23. Now you do the cancellation. If you see here, this is same. So you can directly cancel this. So what you are getting? 100 grams. So in this many number of molecules of calcium carbonate, how much mass is present? 100 grams of mass is present. Okay. So now we will move to the next problem of ours, which depicts calculate the number of oxygen atoms in 1 mole of O2. Same thing, identify the two relations here. Calculate the number of oxygen atoms in 1 mole. So it is the relation between what we are talking about? The relation between an atom and a mole, right? Atom and a mole. So who is the element or molecule they have given? They have given you O2. That is the oxygen. So we will write the standard now. You can correlate the standard here. Atoms means standard is what? 6.022 into 10 raised to 23. And mole, what is the standard? Always 1 is the standard. Now we will go with the problem. Calculate the number of oxygen atoms. What they are telling? Calculate the atoms. So atom side I will put a x. Whereas they have given you the mole. How much mole is given? Here it is 1 mole is given. So I will write it as it is. Now again you do the cross multiplication here. So x into 1 is equal to 6.022 into 10 raised to 23 multiplied by 1, which is nothing but x is equal to 0.22 into 10 raised to 23 molecule of O2. Okay, so we'll go with the next problem now. The next problem it says that calculate the number of copper atoms in 0.635 grams of copper. Now again you find out the two relations here. Now calculate the number of atom you have identified in 0.635 grams of copper. When I am saying 0.635 grams, what does it mean? It means mass, it means mole, or it means volume. Everyone knows this. Grams means it is nothing but a mass. Correct? So it's a relationship between again an atom and a mass. So we'll write the standard. It is with respect to what? Which element? A copper atom. So what is the atoms here? Standard 6.022 into 10 raised to 20. Correct? And the mass depicts that the copper mass. How much is the copper mass? Atomic mass? It is 63.5. 63.5 grams. What they have told in this case? They have told you calculate the number of copper atoms. So I will say this side x and mass of this is already given, it is 0.635 grams, correct? Now you go with the cross multiplication here. X is equal to 6.022 into 10 raised to 23 will be multiplied to the 0.635 divided by 63.5, correct? Now you can directly cancel this, and this can be written as 10 raised to minus 2, which is nothing but x is equal to 6.022 into 10 raised to, this will come here, will become 10 raised to 21 atoms of copper. Clear? We'll go to the one more problem. Now you see this problem, calculate the number of molecules in 11.2 liters of SO2 gas at NTP. NTP depicts that normal temperature and pressure. Okay. Now calculate the number of molecules. Again, you identify the two relations. It is a molecule, and a liter is depicting what? Volume, right? So it is a relation of molecule and a volume. Who is the element here or molecule here? SO2. We'll write the standard here. What is the standard? Molecule 6.022 into 10 raised to 23 molecules, a standard one. Whereas volume is standard is what? 22.4 liters. Now based on this problem, you see here what is given and what is asked. Calculate the number of molecule is asked. So I'll say x this side, whereas there the volume is given how much? 11.2 liters is here. Same thing, now you do the cross multiplication here. This will be 6.022 into 10 raised to 23 multiplied by 11.2 liters divided by 22.4 liters. Correct? Now if you cancel this, this 1, this is 2, which is nothing but 1 by 2, and you are going to get 6.022 into 10 raised to 23 multiplied by 0.5. Now if you multiply this 5, then you will get around 3.011 into 10 raised to 23. Okay, so this is the molecules I'll write, molecules of SO2. Okay, next is we'll try one more molecule problem here. Calculate the volume of 20 grams of H2. I'll just give the relations to you. Again, calculate the volume they have said, and again this is a grams. Now it will be very easy for you. It is a volume and the mass. So volume depicts that it is H2. Volume depicts that it is 22.4 liters, whereas mass depicts that it is H2. What is the mass? 2. Now we'll go with the problem here. Calculate the volume. So this side I will put an X, and this side it will be 20 grams. Correct? So it will be X is equal to, if you do this, then it will be 22.4 multiplied by 20 divided by 2. Correct? So if you do the cancellation, this will become 10. Then X is equal to, it comes to 224 liters. Okay? So this will be this much amount of the volume of the hydrogens. Now, hope you can try these things. The relation only I will tell. This is a mass you can consider, and these many atoms you can consider. Okay? So it is a relation of mass and atoms you can say. This mass of what? It is oxygen atom, so it is a single O I'll say. Now it is a mass when I am saying it is a oxygen mass. What is the standard? 16 grams. And atoms is what? It will be standard 6.022 into 10 raised to 23 atoms. Correct? Now when I am writing as per these calculations, calculate the mass. So this side I'll say X, and this side it will be 12.044 into 10 raised to 20. Okay? Now we'll go with the cross multiplication. 16 into 12.044 into 10 raised to 23 divided by what will do? X. So what is the X? 0.22 into 10 raised to 20. If you do the cancellation of this, you will get 2, which is nothing but 32 grams of oxygen atom. Okay? Now, if you see here, this is a little bit different. Now you understood thoroughly how we are finding the number of atoms, number of molecules, number of amount of mass or volume in this particular calculations. Now you will see little bit different questions where they have asked you how many atoms of hydrogen are there in 34 grams of ammonia. Now you directly cannot use a mole concept here, because you see here how many atoms of hydrogen they have asked, whereas the mass is not given of a hydrogen, the mass is given of a ammonia. So that means this is not a direct problem. Direct everywhere, wherever we have done, it was a direct problem. Here it is like one particular atom they are asking from the entire molecules. So this is little bit different way we have to try. So what we will do in this case, if you wanted to find out the how many atoms of hydrogens in this particular amount of the ammonia, what you will do, first we will find out the mole, because the best way is to go from mole to the atoms rather than mass to atom. So anywhere this type of the problem is given, first you convert this particular entity into a mole. So here the mass is given. So what you will do, first we are going for mass to mole. Okay, with respect to what? NH3. Okay, now what is the standard? How you write the standard? Standard of mass of what mole? A molecular mass of NH3 is what? It comes to 70. Correct? Now here in this case, mole is what? 1 mole. What is given? 34 grams is given as per the problem. If you see 34 grams of ammonia is given, then how much mole it will be? So if you do this, then you will do the cross multiplication. You will get 34 divided by 17, which is nothing but 2. So we understood that we are getting the 2 moles. So that means I can say that 34 grams of ammonia is having 2 moles of ammonia. This is the meaning of it. 34 grams of ammonia is nothing but 2 moles of ammonia. Is this clear? Now you see that we are going to the actual problem now. How many atoms of hydrogen? Now we are going to relate the atom of hydrogen with respect to ammonia. When I say this, 1 mole of NH3, what does it mean? This means that 1 mole of NH3 means that 1 mole of nitrogen, 1 mole of nitrogen and 1 mole of, sorry, how many hydrogens are there here? 3. So it will be 3 mole of hydrogens. You understood this? From this molecule only I have written, if it is a 1 mole of this, it means that 1 mole of nitrogen and 3 moles of hydrogens. Now you see here, how much amount of moles we are getting in this particular problem for the ammonia is 2 moles. So for 2 mole of ammonia, what you will write? If suppose this is for 1 mole, then 2 mole will be what? You will multiply these atoms to this 2, no? So nitrogen is 1 here and number of moles are 2. So it will be 2 moles of nitrogen. And here hydrogen is 3 and 2 moles. So it will be 3 into 6. So it will be 6 mole of hydrogen. Correct? So what we have understood now, in 34 grams of ammonia, there is 2 moles of ammonia here. And in 2 moles of ammonia, how many moles of hydrogen is present? 6 moles of hydrogen is present. Now as per that 6 moles, so I can say that they have asked you what? If you see the earlier slide, you will understand how many atoms they have asked us. How many atoms? They have not asked us the mole. We have found out the mole. Now from mole we will go to the atoms. So here we are going to write with respect to the relation atom and a mole. Now who is that? A hydrogen one. So what is number of atoms here? Standard 6.022 into 10 raised to 23. For how many mole? 1 mole of hydrogen. So that means how much mole we have got as per the earlier problem? How much mole we have got? 6 mole we have got, right? So 6 mole, I'll write 6 this side and this side I'll write the x. So it will be x is equal to 6.022 into 10 raised to 23 into, okay, so x is equal to, if you multiply this, it comes to 36.132 into 10 raised to 23 molecules or atoms, I'll say, atoms of hydrogens. So this is what they have asked. If you check here, how many atoms of hydrogens are there in a 34 grams of ammonia? So you will say it is 36.13 into 10 raised to 23. Okay, so that is it for today's session. Do comment which topic you want for the next session. Thank you.